Hi there, this is Dr. Everybody with Project 9. Actually, Project 9 was created by one of our TAs, Pranchu, PhD student studying security. So this is really a project about security and how do you crack passwords. So the basic idea with passwords is that when a computer stores a password, it should take your password, run it through a function, and encrypt it, throw away the password. It keeps just the encrypted part. So if you attack some computer, you'll find a file of these encrypted passwords, and what you'd like to do is find out what the actual password is, not the encrypted one. And the problem is that this function that's used to create it, it's one way. You can only go that way. It's not possible to reverse the function. So what gets done is you know the function, and so you take all the possible passwords and encrypt every one and make a file that has the password and the encrypted. And now if you find, you attack a computer and you find a set of encrypted passwords, you now have this huge table. It might be petabytes in size. That is billions of gigabytes. And and so what you'll do is you'll basically have a dictionary that's indexed by the encrypted password, and it tells you what the actual password is. So you just go through the encrypted passwords that you have, you look them up in your dictionary, and you find out what the password is. So that's the basic idea of what we're going to do, and there'll be a couple of other things that we'll do at the same time, but that's the basic idea. And this, by the way, is in fact how you crack passwords. And from this, one of the things that we hope you take away, in addition to learn, the Python that we're dealing with here, so you understand the relationship between lengths of passwords and entropy, so that you will in fact be able to create good passwords. All right, so let's take a look at the project. And we're going to be reading some files and so on. So of course we have an open file. All right, we've had these before. So, we throw a little bit of variation in there that there's a default. Okay. All right, so the first one up is checking characters. What's that going to do? So what it does is we will check to see whether some string has some other strings in it. So for example, suppose I have a password. Oops, a password here. And you can see it's got some letters, and it's got some numbers, and it's got other symbols in there. And so what we do is we will take password as the first argument. That's a string there, that guy. And then we also pass in a second one is, are these guys in there? So we go through string.punctuation and see, which actually includes the plus, okay, is that, is there any punctuation, anything that's in this file, in the password? And of course the answer is true. You do the same thing with digits. Are there any digits in there? And the answer is true. Are there any uppercase letters in there? And the answer is true. Are there any lowercase letters in there? And the answer is true. So this is a way for us to take a look at a password and find out, oh, does it have uppercase letters in it? Does it have digits in it? Why do we care about that? Because that will tell us about how good a password it is, and that's what the next function is about. And so the word that's used is the entropy of a password. That has to do with how hard it is to crack. And so what we're going to do is we're going to pass, this function will be passed just a string, that is a password, and it will calculate the entropy, which comes back as a float. And by the way, at the bottom, that float will be rounded to 2 decimal places. And the formula we give you here, entropy, it's just L, and we'll see what L is, and the natural log of n. I'm sorry, it's not the natural log, it's the log base 2 of n. And so the two inputs are, and this, by the way, just comes out of the math function. You've got that in there. So what we need, two things, are the L and the N. Well, the L is easy because that's just the length of the password. So we just take our string and we find out what its length is. That's L. All right, that's easy. You guys know how to do that. How about N? Well, N is what this is all about. This is how we figure out N. And all right, if it's the empty string, we just simply return to 0. If there are only numbers, nothing else in there, then the value of n is 10. If there's only special characters, and what are special characters? We're defining special characters to be whatever is in string punctuation. So this right here is testing for special characters. And what this is saying is that it's only special characters, no digits, no letters, nothing else, right? And you just go through all of these possibilities. And so this is just a bunch of if statements with ands and ors and things like that to figure out what each of these ends are. So, for example, the last one here, it has lowercase, it has uppercase, it has numbers, it has special characters, has all those things, then the n is 94. What might be, what I found useful to do is I actually created a bunch of booleans here, and where I went and I checked, does it have numbers? True or false? Does it have special characters? True or false? Does it have lowercase? True or false? Does it have uppercase? True or false? There's 4 booleans there, and then once I've actually determined what those are, then I can say, oh, if it has numbers, doesn't have special characters, doesn't have lowercase, and doesn't have uppercase, then I know the n will be 10. And you can just go whole series of if statements. Once you get into the rhythm of it, it's relatively easy. So this is all based on this function here. The L is the length. The n is going to be determined by all these if statements, and many, if not most of those, will be based upon checking the characters. And like I said, kind of a cool thing, a neat way to do this, to give you easy reading code, is to come up with booleans for the numbers, the special characters, the lowercase, and the uppercase. All right, so now we can calculate this thing called entropy. Now we start to get to the good stuff. So I told you about when we crack a password, one of the things we need to do is build up a dictionary of all, a bunch of passwords and their encrypted value. So what this takes is, a password file. And for example, if I look over here, the password file that might come in there would be something like this. All right. And by the way, this password file is ordered from most common to least common, and these are real passwords that people have collected on the internet. And yes, in fact, the most common password is 1234556, and the second most common password is password. There really are that many stupid people out there that do that. I'm sure none of you guys have this. And so we call this the rank. So as you read through the file, you just count these, that's rank 1, that's rank 2, and rank 3, and so on. And that's the rank that we're talking about here. All you're doing is counting, because this is an ordered file. All right? And then we have a smaller one to deal with. So what you do is you take each password in there and you run it through a formula, and so if we take a string password, so I read the 1 2 3 4 5 6, which of course is a string, and then what I will do is actually just use this formula. That is exactly the Python, and entropy equals that. Don't use E, use entropy, or some word like that. And that gives you an MD5 hash, and so that's what goes into your into the first item, right? Your MD5 hash, and then the password. That's the 1 2 3 4 5 6. All right. Its rank. In this case, this is rank 1, and then we call that entropy function that we just wrote, and that gives us the value of the entropy. So we get this hash that we create is the key, and then the value is a tuple which has the password, the rank, and the entropy. So this calls the function that we just wrote. The rank is just counting as we're reading through the file. The password is the string that we get out of the file, and the MD5 hash is this function right there. And so we build this large dictionary out of, it's like, here's all the common passwords. And so if I'm trying to, crack passwords, let me start with the common ones, right? It just seems like a logical thing to do. So as an attacker, that's that will be the first thing I will try. All right, so now I have this dictionary of all these common passwords indexed by their, with the keys as the encrypted version of them. Now I can go about cracking. And so the way this is going to work is I'm going to take this dictionary, and I'll pass it to that function. And this file pointer, well, that file pointer is going to be the password, the encrypted passwords that the hacker has collected. And so that is a file that looks like this. So I'll slide it over here a little bit. And so how does this file look? Well, remember, we grabbed these, so these are all the encrypted passwords, right? So these guys here, when I look through my dictionary, those are the MD5 hashes. So I'm going to read this file, and I'm going to take each value, each encrypted password that I have, look it up in my dictionary, and if I find it, if I find the encrypted, then I know what the password is, and I have cracked it. And so what I'm going to do is I'm going to return a list of the passwords, and a list of tuples. Actually, for each one of these, it'll be this tuple, the password, the rank, and the entropy, and then I will have a count of I will have the cracked count, and I'll have the uncracked count, and that will add up to the total number of items in this file that I just read. And so all we just get a count. How'd we do? How many did we crack, and how many did we not crack? So all we're doing here is we're reading through this file, and for every one of these, we just look them up in the dictionary. And this is actually how somebody, when you read in the news, oh, somebody found all the passwords on, some site on the internet. That's what they've done. They found they grabbed all the encrypted passwords, and then they take them offline, and they crack them in this way. Now, sometimes, it does turn out that they aren't encrypted, and that's a particularly stupid site. So that's the core of what this project is all about. There's a couple other things, like there's looking for patterns in passwords. So for example, the password has the word pass and password and word in there, and and so what words are we looking for? Well, we have 3 sets that we provide. There's a set of common English words, there's a set of names, and there's a set of phrases. And so we're just looking those up. Beyond that, the main is really, you can see it here, there's a banner that is done with an ASCII key. That's what we're trying to do with that. And we put a prompt out. We can calculate the entropy. That's calling the entropy function. We can crack a password table. That was the passwords. And then we can locate common patterns. That's that final function. So in this case, it asks for a password file. That's the small file. That's actually this file. It just has half a dozen possible passwords in it. And then the same thing, it's got a few hashes, and then it outputs what it cracked. All right. And so in this case, it cracked 7, and it didn't manage to crack 20. Puts the prompt out again, and then exits the program. So hopefully that gives you, helps you understand what's going on, gives you an idea of how to do that, and also hopefully it'll be easier than the last project. All right, good luck.